Ladies and gentlemen, this screencast should help you as you prepare to begin the virtual toy cars assignment. You should have a handout that you can use to follow along. For each of these virtual toy cars that you'll see in a moment, you'll have information about how the car moves and how much time it takes to move. So we're going to run through a really quick example. So in this, we have a sentence that tells us the car A begins at a position of -8 meters, and it moves to +4 meters in 3 seconds. And we're supposed to fill in a table that you'll see in a moment. So this shows an example of a car sitting at -8, and then it moves across the screen and stops at +4, making that its ending position. So keep that in mind as we go through filling out this little chart. So the sentence up above is shown again. So you'll notice that we need to fill out the bubbles across the top of the page. So first, what do we mean by direction? If we look at this, the car starts at -8 and moves to +4 as it goes to the right. So that leads us to the conclusion that the direction toward the right is positive and direction toward the left is negative. So we'll follow that convention on this activity. Next, the final position is going to be given by x sub f. The initial position is x sub I. The displacement will be triangle x or delta x. The time passed will be a t, and the velocity will be the equation v equals displacement divided by time, or the longer version of that, which is x sub f minus x sub I divided by t. So be sure that you have those bubbles filled in on the handout so that you'll have that to work from on the larger activity. So now let's go through filling in the bottom part of this. So if we look at this, we're going to fill out the car, the direction, the final and initial position based on the description, the displacement, the time passed, and then calculate the velocity. So clearly it's car A, so we want to put car A in at the beginning. Car A begins at a position of -8 meters, and it moves to +4 meters in 3 seconds. So that means it's moving in the positive direction. The final position, it moves to +4 meters. So the final position is +4 meters. The initial position was -8 meters. It's easy now to find the displacement. The displacement is just the final position minus the initial position. So across the top of this box, we have an example of the calculation, final position minus initial position. So if we have +4 minus -8, that's the same as +4 plus 8, giving us a displacement of +12 meters. The time passed was 3 seconds, so we'll include that in the time passed category. And then we'll gather all of that together in the velocity calculation. We'll put the displacement divided by the time, 12 meters divided by 3 seconds, and find that we have a velocity of car A of 4 meters per second. So for each of these virtual toy cars, you'll see the car move across the screen. You'll fill out the information in a pattern like the small table shown, and then use that information to answer some questions about the relative velocities of the cars that you analyzed, and then graph them on the back of the page. Good luck. Do a good job.